about the VI characteristics of SCR. So in these experiments we are going to record the VI characteristics of SCR. So here in the SCR we have three terminals. One is anode, cathode and gate. And here this is the SCR module used to record the VI characteristics of SCR device. So here there are two knobs are there to vary the voltage applied to the anode and cathode terminal and the current applied to the gate terminal. So this SCR is a advanced version of our diode. So in the diode we have no terminals to control the conduction offered in between the anode and cathode terminal. But in the SCR we have a terminal to control the conduction offered in between the anode and cathode terminals. So this is the major advantages. So based on this we are calling the SCR as a controlled device and diode is named as uncontrolled device. Okay, and we can use these SCRs for controlling the output voltage of a rectifier unit. Okay, and here there are two inbuilt sources are there, and these sources is adjusting the input voltages from 0 to 5 volt, and here one more sources is there to feed 50 volt of DC supply to the SCR module. Okay, so here the SCR is inbuilt, and here there is a provision to connect the voltmeter, ammeters, and this if you are connecting the ammeter here, it will measure the current flowing through the gate terminal, and the meter connected across these points will measure the anode current or the current flowing in between the anode and the cathode terminal, or it measures the current flowing through this loop. Okay, and here we can connect the voltmeter to measure the voltage applied across this terminal. Okay, so either you can connect here or we can connect the voltmeter here to measure the voltage applied across the SCR terminals. Okay, and here I need 3 meters to measure the gate current, and for measuring the gate current I selected 10 ampere meter, and I am going to keep here to measure the gate current. And another meter needed is 500 milliampere, so it measures the current flowing through the anode terminal. So and I am going to keep here, so and I am going to connect there, or we can keep it with some space to avoid the confusion. And this can be used to measure the voltage applied in between the anode and the cathode terminal. So now I am going to interconnect these devices and meters to measure the breakdown voltage, forward breakdown voltage of the SCR, and in order to draw the VI characteristics of the SCR. So here this is the positive terminal. So this positive terminal is connected to the positive of the ammeter, and the negative terminal of the ammeter is connected with the gate terminal of the SCR. So the current enters into the positive terminal of the ammeter and leaves from the negative terminal of the ammeter to gate. So it measures the current flowing through the gate terminal. And here the SCR is a current controlled device, so we are measuring only the gate current, because the conduction offered by this device will depends only on the gate current. So we are using only the current meter to measure the current, and here that conduction will be proportionate to the gate current. And similar to this, I am connecting the ammeter in the anode side. Okay, so this is the positive terminal of the ammeter I connected, and the negative terminal of the ammeter, I am connecting the negative terminal of the ammeter with the anode of the SCR. Okay, so I connected the 2 meters ammeters. It measures the gate current of the SCR and it measures the anode current of the SCR. And now I am connecting the voltmeter across the devices to measure the voltage applied across the anode and the cathode terminal. So if you are connecting the voltmeter here, So whenever this device is in off state, then the meter will read the current flowing through this voltmeter. So better you can connect the voltmeter across these points. Okay. So that can give you the exact value or exact current flowing through the anode circuit. Okay. And this is the circuit connection. And here we used this SCR module to obtain the VI characteristics of the SCR. So I connected all the connections. So now I am going to switch on this circuit. So before that I should ensure the position of each knob. Okay. So it should be in the 0th position. So then only we can protect the devices from the over voltage failure or over current failure. Okay. So I connected this connection, and now I am going to switch on this circuit by power on the button. Okay. So here you see the light is glowing. So now the voltage is applied. So now by adjusting this, I am going to fix the gate current of the SCR. So you see the meter, and it is reflecting when I am wearing the knob, it is gradually increasing. So here I fixed the current at 3.8 milliampere. Okay, so now I am varying the voltage applied in between the anode and the cathode terminal of the SCR. So you see the meter reflection. So now the devices is in off state, so there is no current in the anode. So this meter is reading the 0th value, and this meter is reading the voltage applied in between the anode and cathode terminal. The voltmeter is increasing. So now you see, so nearly when it is crosses 10 volt, the devices comes to conduction, and it makes a short circuit in between the anode and the cathode terminal. You see here, so till now the devices is not breakdown. So again further I am increasing the voltage. So you should mark the voltage and current for this gate current, or for the current of 3.8 milliampere. So for the 0 voltage the current is 0, and when I am increasing this voltage to 1 volt or 2 volt, again the current is 0, and if we are increasing it to 4 volt, again the current is 0. So 5 volt, the current is 0, 6, 7, 8, 9, the current is 0. So now the needle is near to 10 volt, and again I am further increasing this, so it is breakdown, so the device voltage comes to 1 volt. Okay, so here this meter should read, but it is not reading, so there may be an issue with this meter, so we should change this. Here now I changed this meter. So now you see, again I am increasing the voltages from 0, so it is gradually increasing. So now the device is in off state, so there is no current in the anode. If this voltage crosses 10 volt, you see that reflection. So it is in 10 volt, so now the device in off state, so there is no current in the anode. You see this meter also, there is no current. So again I further increase, the device will break down, so the voltage across the devices will comes down. You see here 11 volt, 12 volt, 13. So near 13 volt the device comes to breakdown. So now the device is breakdown, so it voltage comes to 1, and here the current is nearly 20, 40, 60 milliampere. 60 milliampere. So now you see, if you are further increasing this voltage, so this meter reading will not reflect, and you can see the variation in the current. So it means that, so the devices is increasing, that meter is devices is comes to close. That means that the device is breakdown, the device is conducting the current from anode to cathode. Okay, you can see, you can observe the variation of the current in the anode, and this reading should be tabulated for drawing the VI characteristics of SCR. Okay, so here the breakdown voltage of these devices is 13 volt, and we have to repeat this same procedure for measuring the breakdown voltage and to draw the VI characteristics of SCR for different value of gate current. Okay, so I have shown for one reading, and here I increased this for 5 milliampere current, and again you have to repeat this procedure to measure the VI characteristics of the devices for another value of gate current. Okay, so this is about the VI characteristics of SCR.